Hi, I'm Mrs. Burns and welcome to Lesson 8 of our chemistry section. Today we are getting into the next part of this chapter 4, and that is chemical equations. So today we are going to intro chemical equations, and then in the next couple of videos you can anticipate balancing chemical equations. So today, let's start. Chemical equations demonstrate what substances are combined or formed during a chemical reaction. So you already learned the difference between physical changes and chemical changes. So a physical change is one when the phase of the substance changes, but the chemical formula stays the same. So you have the same atoms, the same elements, the same formulas, just the state changes. So for example, you can have water here as a gas, maybe an air. You could have water, H2O, as a liquid. And you could have water, H2O, as a solid, ice. So there's different phases that you can have water in, solid, liquid, and gas, but those are just physical changes. So water boiling is a physical change because it can be reversed. Anything that can be reversed is considered physical. A chemical change, however, cannot be reversed. So this would be something like, for example, cooking an egg on your stove. You can't turn a cooked egg back into a raw egg, so that's a chemical change. The atoms actually rearrange themselves. So from the beginning to the end, the actual chemical formula changes. So for example, if you start with Na and Cl, these are two separate ions, and if you add them together, then you get NaCl, and that is a completely different formula than Na by itself and Cl by itself. When we write a chemical equation, we are representing a chemical reaction. So the substances on the left of the equation that come together, these are called reactants. And the substances on the right that are formed are called the products. So I have here an example for us. This equation, 2NO plus O2 goes to 2NO2. So this 2NO and this O, these are the reactants because they're on the left side of the equation. So the left side of the arrow, basically. And on the right side over here, we have 2NO. This is the product. And there's only one product in this case. Well, I guess there's two NOs, but only one type of product. You can also represent an equation using words. So you could say, well, NO, you could say nitrogen monoxide plus oxygen can yield nitrogen dioxide. So again, these two here are our reactants, and this is our product. In chemical equations, you're also going to see other things like coefficients and the states of matter. So the coefficients are whole numbers. I'm just going to write the number sign, whole numbers, placed in front of each substance in order to show the ratio in a reaction. So similar to our ionic bonding, the subscripts just show the ratio of one compared to another. That's the same thing with these coefficients. They just show how many of one versus how many in another. So we saw that there were 2 NO, 1 O2, and 2 NO2. That's if we go back up here and see this 2, this nothing, and then this 2. Whenever you see nothing in front, it's considered a 1. So there, you don't have to write a 1. It's just basically understood that that would be 1. So it's not wrong to put a 1, but you don't need to. So you don't need to bother doing that. This means that there are 2 nitrogen monoxide molecules reacting with 1 oxygen molecule. And the ratio of our reactants then is 2 to 1. 2 nitrogen monoxide to 1 oxygen. Also, we get states of matter, And letters are used to express our states of matter. And remember that the states of matter are just solid, liquid, gas, and we're also going to talk about something called aqueous. So solid, we can just write a little S next to it. Liquid is an L, and gas is a G. Aqueous we represent with AQ, and that just means that it's dissolved in water. So if you have sugar water, then that you'd call that an aqueous solution because all of your little sugar molecules are dissolved in your water. So here we see that nitrogen monoxide is a gas, oxygen is a gas, and it yields two nitrogen dioxide molecules that are both in gaseous form. So we can write the G's there just to be clear that we're talking about a gas. All right, here's another example. Here we see two hydrogen molecules. Here's one hydrogen molecule. Here's the second to make two hydrogen molecules. One oxygen molecule. Here's the one oxygen molecule. And that yields two water molecules, 1, 2. So here, this is figure 4.32 from your Science 10 textbook. And the reaction of oxygen molecules with hydrogen molecules simply involves rearranging where they are oriented. So the first guy to figure this out really well was an English chemist named John Dalton, and he really searched hard into the changes in atoms during a chemical reaction. He found that no new atoms were ever created or destroyed. So we never made anything new, we never got rid of anything. They only were rearranged. Well, we see here two hydrogen gas molecules. 1, 2 for there goes to 1, 2 over here. 1, 2 for that guy goes 1, 2 over here. And two little oxygen atoms in this one oxygen gas molecule. And then here are our two oxygen atoms in those two water molecules. So they're just rearranged. French chemist Antoine Lavoisier took this idea one step further with the help of his wife when he experimented with the mass of chemical reactions. So they found that the total mass was always the same for the reactants and products. No matter what the mass was when they started, the mass was always the same at the end of the reaction. So they called this idea the law of conservation of mass. So here we have a little diagram that tells us about one of the experiments he did. So here is a closed system. This jar is closed, so nothing is changing about it. And the mass of this jar is, well, the jar, but in both cases, so it cancels out. So it's all of the air inside of this jar, as well as the wood of this match. And then they burnt the match, and they found that the gas, the carbon gas, CO2, the carbon soot on the match, as well as some water that was formed, that the mass inside this jar after the burning of the match, it was the same mass. So that was an experiment that led them to believe that mass didn't change. We're going to be investigating this idea further next class in our Law of Conservation of Mass lab. So please come prepared. You may want to read this section 4.3 of your textbook before coming to class so that you are well prepared for the lab.